Okay, cellular stuff. Who has any familiarity with 3GPP or LTE protocols? He does. I have one. Anybody else? Jim? Okay, good. So this is going to be an introduction. We have 10 minutes, and we could probably overflow to tomorrow. So why don't I do this? I've got probably about 10 minutes on cellular background on the standards organizations and the history. We'll break there, and tomorrow we'll dive into LTE before we get into hands-on. I think we have enough time tomorrow. We gave plenty of time for the hands-on tomorrow, so I think we'll cover LTE protocol tomorrow for about half hour, 45 minutes, and then we can jump into hands-on exercises. How about that? Sound like a plan? Okay. Organizations that you need to worry about. ITU and 3GPP. So just like we had WinForum and CBRS Alliance for the CBRS spectrum, from an LTE protocol perspective, you need to know about the ITU and you need to know about 3GPP. There were some other organizations back in the past, like 3GPP2 for CDMA stuff. Don't worry about it. Not relevant today anymore. ITU is responsible for global spectrum coordination, so worldwide. They have a conference every 3 or 4 years, where they go through and do alignment and proposals for, hey, what's upcoming? What do we need to plan for on a global basis? So they held one and they talked about upcoming 5G recently. And then what they do is the technical standards are all defined by the ITU. The 3GPP is not a standards organization. They're not like the IEEE. They're not like WinForum. They do not develop technical standards. They develop what they call technical specifications. So the difference there is ITU sets the requirements. 3GPP says, here's how the specifications that we propose to meet those requirements, and then the ITU approves them. So ultimately, the standard is ITU. The 3GPP is just a specifications and proposal committee. It's very confusing. When you look at their stuff, it looks like technical standards. It is technical standards, but they're not a technical standards organization. They don't actually, they aren't responsible for approving it. It's the ITU. Make sense? Clear as mud? Okay. The 3GPP is broken down into working groups and task groups. So there's 3 primary working groups. There's the RAN, which is all the radio side stuff. There's the core network and terminals, which is like all of your core stuff. And then there's the service and system, which is like the overall architecture, security, and things like that. The thing you should know about this is everything gets approved through the one on the right-hand side. That service and systems aspect working group is the primary working group. It has to approve all the specifications from all the other groups, from the other 2, and from all the task groups within them. So the main body here is the right-hand side one. And then within those, you have task groups for different aspects of the protocol. So, RAN working group 1 is for, layer 1 PHY stuff on the radio. Working group 2 is for the MAC and layer 3 stuff on the radio side. And so you get, they break out into very functional task groups. The history of the generations of cellular service. So started actually prior to 1981. It's actually, cellular stuff goes back to 1947 actually, but I didn't put it on the slide because it was kind of irrelevant. But there were a lot of AT&T and FCC started to work on radio communications in 1947. And so there were a lot of like legacy proprietary, very, very limited use deployments between 1947 and 1981 by AT&T. For very specific radio communications needs that eventually evolved into the cellular standards. 1G, big thing to know is it was all analog. 2G really brought in digital voice, but it's still circuit switched. So, if anybody's familiar with circuit switch versus packet switch sets up an end-to-end communication path that reserves resources end-to-end before in setup of a session. So with 2G, we actually started setting up, it's still circuit switched, setting up an end-to-end call, but we just used digital modulation, or digital instead of analog modulation. 2.5G started bringing in data service over that circuit switched path. very, very low data transmission rates, like kilobits per second. This is where you get into like GPRS and CDMA starting to come around. 3G is really, that's the one that really became widely known and popular for a data service network. In 1999, we had, a couple of megabits per second in speed, and we had a breakout between different standards organizations implementing different technologies in different regions of the world. So we had 3GPP mainly in Europe doing essentially UMTS service, which is built off of GSM. And we had 3GPP2, which was CDMA-based technology being used in the US. So back in the day, if you're old enough, you probably remember, hey, I had a certain operator's phone. I couldn't take it internationally because it wasn't a GSM-capable phone. It was Verizon primarily. AT&T did GSM, so you could take some phones internationally, others you couldn't. There was a bifurcation in the standards completely. What's interesting, just a wrinkle, is that we always think of Europe being GSM, but that's really a 2G technology. For 3G, they actually did a version of CDMA. So we always think of, US was CDMA based and Europe was GSM based. Well, for 3G, actually both were CDM based, just different versions, flavors of CDMA. It's very weird. And so then when you get, Edge service was the UMTS 3GPP equivalent. And EVDO was kind of the 3GPP2 CDMA US-based equivalent. So when you remember those terminologies, just remember Edge was one, EVDO was a data service from the other one. And then 3.5G, they just increased the speed. That's where you got HSPA. In the 3GPP world for the US, or for the 3GPP2 world, you got ultra mobile broadband. I think this is where you start to see the 3GPP taken over again. HSPA was much more popular. And when we get to 4G, Verizon was the one who did the CDMA 2000. They were the oddball. With 4G, Verizon went to the dark side with 3GPP and the LTE standard. And so everything kind of remerged. So that's why everything's kind of standardized again. You don't have to worry about which phone model, because essentially when Verizon decided to go back to the 3GPP version, the CDMA 3GPP2 version kind of just died off. So 3GPP2 is not a thing anymore. It's not an organization anymore. Nobody uses it. It's just historical reference. And then you go back one. 3GPP release 99 was 3G's original version. So you see release 99, and that means 1999, 3GPP's initial 3G release with UMTS. And then they started changing their numbering based on just incrementing numbers after that. And so you really get into release 3, 4. Release 8 was LTE or 4G. And the big thing there is they overhauled the system architecture. So you get into what's called system architecture evolution. And this is an all IP-based architecture. So prior to 4G LTE, you had stuff that was still not all IP-based. It was still potentially some circuit switched, legacy protocol based. They overhauled it completely and you get all IP. Some of the terminology in there is all IP network is the same as an evolved packet core. So getting into some of the terminology of if you see these, when you start learning LTE or learning the technology, these mean essentially the same thing. And evolved UMTS, terrestrial radio, or EUTRA, is just the exact same thing as LTE. It is the air interface for the system. It brought in MIMO, it brought in OFDMA, it brought in FDD and TDD options for the protocol. So if you are having paired license spectrum for frequency division duplexing, one frequency band or channel is uplink and the other channel is downlink, you've separated them onto different frequencies. Or you're doing TDD, which is what we're doing in CBRS, which is all on one channel. Your time division duplexing on the same channel, uplink, downlink within the same channel. Other big things there, release 10 brought in LTE advanced, higher speed, we get higher MIMO. We start to get carrier aggregation, meaning just like you have wider channels in Wi-Fi, we're starting to get carrier aggregation across multiple radios. And so each radio can have what's called a component carrier. So that can be let's say in release 10, it was up to 20 megahertz. You can combine multiple radios, just like you have dual radio APs, you can have both radios operating together for carrier aggregation. So it's a little bit different than Wi-Fi on just how wide the channel is on one radio. Carrier aggregation in LTE is aggregating the bandwidth and capability of multiple radios that are hardware based. So if we have a 2-radio eNode B here, if we do carrier aggregation, both radios are looking as one cell with potentially 40 megahertz, 20 on each. And I'm almost out of time, but that's good, we're almost done. Let's see, what else is big here? This is mainly just reference material for you, so when you get the slides, you have some basis for reference. Release 14, 2017, we got band 48 defined. Band 48 is the CBRS band. So it was, 3GPP they incorporate every band that is supported and they have it in their specs. And there's, all sorts of different implications for that in the specs. Band 48 and the definition of that band came in 2017. And then release 15 and release 16 are going to be 5G stuff. Just so you know, when we talk release 15, we're talking 5G, new radio stuff. Yeah, I mean, the other thing you guys might care about is release 13, they started to do LAA stuff. Remember that? When that was a big deal? We might start to see it actually get deployment in 6 gigahertz, so it might come and affect you, but I haven't seen much of it yet. 256 QAM support. Yeah, I mean, they start to do all sorts of funky things with interworking with other technologies, starting with like release 12 and on. So, but this is just a snapshot. There's a lot of technical detail on all these releases that I'm skimming over, and half of it I don't understand, so I didn't put it on the slide. And then this is the last slide for today, and then we'll break. So I really appreciate your patience today going through a lot of slideware. Tomorrow we'll just do LTE and then hands-on, and we'll have a lot more fun, hopefully. This is just the capability of, based on cellular generation, what the peak data rate was, and for a macro network, what the typical download speed is. But again, take that with a grain of salt. That's a macro network under, typical loaded congestion in different markets and things like that. So you can see, yeah, with LTE, the speeds have ramped up quite dramatically. So LTE Advanced, technically you can get almost a gigabit of raw data rate. So it's fairly equivalent to where 11AC is kind of at, depending on channel width. And 5G is going to take that to multi-gigabit, again, based on carrier aggregation and, combining multiple radios and multiple channels and millimeter wave and all of that. So, the question is AT&T's 5G evolution. That's actually LTE Advanced technology. It's not 5G. So, I think same marketing tactics that you're used to as people want to claim something is the greatest first to market. Yeah, whatever.